Hello, everybody. Today we're going to talk about VFR flight planning. Today we're going to be using a sectional chart. Sectional chart gives us good scale so that we can see quite a bit of land on just one sheet. There are a couple of different types of charts that are available. One is a tack chart, which would be basically just a small section, say Tampa. The other one is a much bigger scale, which is a whack chart, which would show pretty much a whole state at a time. So if you're going a long way away, you're going to use a whack chart. If you're using a sectional for trips that are maybe 200-300 miles apart. So let's get started. First off, we've got some tools. Obviously the sectional. The other tool is our plotter, which is a handy tool. It needs no batteries. And what's called, affectionately called, the whiz wheel, or the E6B2 computer. Also needs no batteries. And the last thing we're going to use is the VFR Flight Planner sheet. It's going to logically let us walk through the flight planning procedure. So let's get going on our flight today. The flight we're going to take is from Tampa Executive, up here by Tampa, and we're going to go down to Sebring Airport. It's going to be over 50 miles. So therefore, it will be loggable as a cross-country flight. Anything over 50 nautical miles goes in your logbook as a cross-country. So step one that I always do when I'm looking at a cross-country flight like this is the big picture. The big picture is from Tampa to Sebring. Is there anything that is noteworthy that I'm going to use for VFR flight? Because I'm keeping my head outside the window, I want to see anything that I'm going to be passing by. So as I'm going from Tampa Executive, I might, along this route, I might look to the left, and there's Plant City over to the left. And then also the series of antennas we call the Riverview Antenna Farm, big antennas over there. And then as you continue southeastbound, there are a series of smaller highways and so forth. Not a whole lot out in this area, but then we have Highway 17 right here, which goes from Wauchula and it goes northbound. It's pretty easy to spot. And then as you keep on going down to the southeast, the next waypoint would be Avon Park. You notice Avon Park is almost directly in line with our flight path. So we're going to pass almost directly over top of Avon Park. And then finally, when we get close, nice and close to Sebring, you've got the lake. That lake is very, almost a perfect circle, and it's got a city built all the way around it. So once you get to that lake, you're only going to have about 4 miles to go before you get to Sebring Airport right there. If you go too far and you go over top of a big lake and it has no city around it, you know you went too far. Time to turn around and go back. Okay, so that's the first step. Just to notice, I picked out a few landmarks along my way. That breaks up the trip. Every cross country of 500 miles is just a whole bunch of small little 25 nautical mile hops between waypoints. You always want to pick a waypoint about every 25 miles because that's about how far you can see from the airplane. All right, my next step is I'm going to write on my flight planner, I'm going to write from VDF, which is Tampa Exec, to SEF, which is Sebring. What altitude am I going to use? Well, I'm going eastbound. I'm on the eastbound side. So I'm going to use an odd altitude plus 500 feet. So the lowest odd altitude above 3,000 feet, anything below 3,000 doesn't count. But anything above 3,000, you'd have to add 500 to the odd altitude. So I'm going to take 3,500 feet, 3,500 feet. Okay. Now, the next thing I have to get is my winds. I checked my winds and they're 090, so they're from the east at 10 knots. We're going to make it pretty simple as far as our winds. Remember, they're from the east, so from 090, they're coming from this direction. So that makes a slight headwind. We're going to have about a 10 knot or an 8 knot headwind when we do our calculation. All right, so on the flight planner, the next thing I'm going to check is my magnetic heading. And on my flight planner, I actually cheat a little bit. I say use the plotter and the sectional. So my plotter has a series of marks on it. Notice that this is the nautical side of the plotter. Because my airplane is in knots, I'm going to use the nautical side. If you flip it over, you'll see statute miles. So if you have an older airplane and you're using statute miles, you're going to use this side of the plotter. If it's a newer airplane, basically newer than 1975, it'll be in knots, nautical miles. And you can see right here that we have on the sectional scale, it shows us from 0, 5, 10, and so forth. And we can also use on a wax scale. And you notice the wax scale is twice as dense, or twice the scale as the sectional. All right, so first things first is I'm going to take my plotter and I'm going to start at Tampa Executive and I'm going to lay my plotter down like this. So now I'm going to go from here, from Tampa Exec, all the way down to Sebring right there. And now this little wheel right there, some plotters are different, but this little wheel right here, all I have to do is point it straight north. And I'm going to guess at it right now. This is not exactly, I might be a couple of degrees off, but I'm going to point it straight north on my sectional. And I'm going to see that I got about a 120, somewhere around 120 heading. But this isn't perfect. I need to do a little bit better job of getting a perfect heading on here. And the way I'm going to do those, I'm going to take my grommet, that's the center point right there, and I'm going to find a longitude or latitude line. So right now I've got a very convenient line of longitude right there. I also have a line of latitude right here, but this is a little bit too far south for me to use my plotter. So I'm going to use this line of longitude right there. I'm going to take my grommet and I'm going to slide my plotter, keeping the two airports under there. I'm going to slide my plotter so that the grommet is directly underneath of my line of longitude in this case. So there's the line right there. And that's why they make this transparent so that you can see it. You can just barely see it right underneath there. So now I was only a couple degrees off, so I'm going to just position that line right there so that it lines up with my line of longitude. And I'm going to read my heading. My heading is going to be 125 degrees. 125 degrees. So I put that on my sheet. Okay. And now that I know my heading's going to be 125, I can figure out on my sheet, I can figure out my wind correction angle. And again, I'm using my little notes here. Wind correction angle, WCA, comes from my whiz wheel or my E6B. It doesn't come from this side, it comes from the opposite side. The nice thing about the whiz wheel is all the instructions are at the top. So the first instruction says, set the true course, that's my 125, under my true index. And if you're guessing about it, that's the true index mark. So I'm gonna bring this up here like that. And so I'm gonna put 125 right underneath that true index mark. So 125 is right there. Put it right underneath the true index mark. Okay, now, what do I do now? I set the wind direction arrow opposite my wind direction on the compass rose. So here's the compass rose around there. And remember my winds were 090. So I'm going to take my wind direction arrow and put it right underneath the 090. Okay, so there's 090. And again, this is wind at altitude. This is not the wind on the ground. This is wind at altitude. which we get from aviationweather.gov or various other sources. All right, what's step 3? Step 3 says slide the true airspeed of the aircraft under the wind speed of the yellow scale. So the wind. Now I need to slide the back slide, and I need to put my true airspeed under the 10 mark because it's 10, remember it's 10 knots. Need to put it underneath the 10 mark of my wind meter. So right now we're up at 200 knots, so no way the Cessna's going to do that. So let's move that this way. And I'm going to go for 80 knots. That's my true airspeed. So there's my 80 ring. So I'm going to take the 80 knots and I'm going to put the 80 knots directly under the 10 mark, which is right there. Okay, so I've got the 80 mark. That's the 80 mark. And I've got it right underneath my wind speed, right there. So now, the next thing is looking at the instructions. Read the ground speed. This is number 5. Read the ground speed under the grommet. So the grommet is the center point right there. And the grommet shows right at about 72, maybe 73 knots. So here's 70 right there. So it's right about 73 knots. That's what my ground speed is going to be. Again, you've got a headwind coming in from the east, so you've got to factor that in. So 73 knots is what our ground speed is going to be. So I'm going to put that there. And at the same time, we've got our wind correction angle. And here's my wind correction angle. It's off to the left. And these lines, these vertical lines that kind of fan out a little bit, those are the angles. So here, this would be 0. So if my wind line was going up this way, it'd be 0 degrees. But it's going off to the left. Here's 10 degrees. So if I look right up there, there's 10 degrees. And these divisions are 2 degrees apiece. So 10 degrees, there's 8 degrees, 6 degrees, 4 degrees. So I'm right at about 4 degrees. And because I'm on the negative side, it's negative 4 degrees. So my wind correction, I've got to steer slightly left, of course, about 4 degrees, left, of course, in order to maintain my track. So left minus 4 degrees, minus 4 degrees. And that kind of makes sense because if you're going in this direction and the wind is blowing from this way, it's going to push you to your right. So you have to steer to the left to counteract that wind that's coming at you. So I now have my wind correction angle here, and I also have my ground speed. Doesn't mean you don't have to do everything in order. Get things, take advantage of it. Get things as you come across them. Okay, now the next thing is the magnetic deviation. Magnetic deviation is found on the sectional by finding the magenta dashed line right there, and it goes up and down like that. That's my magnetic deviation number right there, 6 degrees west. Now what this is the variations in the magnetic forces around the Earth. They're not uniform, so there's a really long, hour-long description of just why, but they're not uniform. Go up in the Northeast, they're 15 degrees off. Go up in the Northwest, they're 20 degrees off. Luckily here in Florida, they're only about 5 or 6 degrees. 5 degrees is over there, just off the Gulf, and 6 degrees. The thing is, through time, this moves around. This has moved about 3 degrees since I became a pilot, so it's quite a bit. So we have again, 6 degrees west. Now coming back to my flight planner, east variation or deviation would be a negative number, west would be a positive number. So We're 6 west, so it's plus 6 degrees correction. And that's what the compass is lying to you on. The next block is the compass deviation, and that every airplane has little variations in it. Somebody used a magnetic screwdriver or what have you around the airplane, so the compass has this deviation card, and every heading that you could go onto with your compass will show a deviation. So for right now, we're just going to say 0, although it's rarely 0, but for our calculations right now, we'll just say 0. So now the total correction is going to be 3 items. It's going to be my wind correction, and it's going to be my deviation, and it's going to be my compass deviation. So this plus this plus this. So -4 plus 6 plus 0 is plus 2 degrees. So I have to actually add 2 degrees to my track in order to compensate for the wind and for the compass lying to me. So my compass heading on this flight, factoring in the wind and all the deviations, my compass heading is going to be my magnetic heading plus the compass, or all the corrections. So my magnetic heading is 125, and my corrections is plus 2. So my compass heading on this flight will be 127 degrees. All right, cool. The next thing we got to figure out right there is our distance. Very simple to do. Again, use the nautical scale on the bottom. That's 0 right there. Goes out to 10, 5 and 10 and 15, so on. So I'm going to take and put 0 right on Tampa Executive. And I'm going to slide my scale down here to Sebring. There's Sebring. And I'm going to read that number right there. And if you look at it, it's 63. So here's 60, 55, 60, 1, 2, 3. 63 nautical miles. All right, very good. We're now finished with our plotter. But now it's time to take the whiz wheel and flip it over and use the calculator side of the whiz wheel to figure out 2 more things. First off, we want to figure out what our leg time is. The leg time is our distance factored in with ground speed. So the whiz wheel, to take the mystery out of it, the whiz wheel 60, big black 60 with an arrow, that's 60 minutes. So in 60 minutes, how far will I go? Well, my ground speed is going to be 73 knots. So I'll go 73 nautical miles. So in 60 minutes, I'm going to go 73. So there's 71, 2, 3, 73 nautical miles. In 60 minutes, I go 73 miles. We only have to go 63 miles. So remember, the outer scale is miles, the inner scale is time. So that's 60 minutes, 55 minutes, 50, and so on. There's 70 miles, 65 miles, 60 miles, and so on. So on my outside scale, I'm going to look at 63 miles. So 61, 2, 3. 63 miles is going to take me 50, we'll call it 52 minutes, maybe 53. I'm going to call it 52 minutes. 52 minutes to fly 63 miles. Does that make sense? Sure. We're going more than a mile a minute at 73 knots. So it makes sense. 63 nautical miles at a rate of 73 miles an hour. We're going to take 52 minutes. Now, in 52 minutes, how much fuel am I going to use? Again, that's 1 hour. 60 minutes is 1 hour. And how much fuel am I going to use? So instead of miles on the outside scale, now I'm going to use gallons. In 60 minutes, the Cessna 150 will use 6 gallons an hour. So in 60 minutes, 6 gallons an hour. So instead of 60 minutes, I am going to be flying for 52 minutes So in 52 minutes, let's get this back up here. In 52 minutes, I'm going to use 5.2, not 50. That doesn't make sense, right? 50 gallons? No, 5 gallons. 5.2 gallons. 5.2 gallons in 52 minutes. All right. So now I've got my flight plan all worked out from Tampa Executive down to Sebring. And now all I have to do is turn the process around and go back the other way. Well, my winds haven't changed. The only thing that's really changed is what's my heading? Well, the heading's going to be 305 degrees going back the other way. You notice I didn't even have to turn the wheel because I already had it set. So it's going to be 305 degrees. So really all I have to do is start filling in my blanks. 305 degrees. I'm going to find a new wind correction angle. The magnetic deviation didn't change. The compass deviation didn't change. So I just have to come up with a new correction, total correction and compass heading. The distance hasn't changed. What has changed definitely is the ground speed, because instead of a headwind now, we're going to have a tailwind now. So again, I'm going to use my whiz wheel to figure that out. And my leg time, because I have a tailwind, will be a little bit less, as will my fuel required. So when it's all said and done, I'll know exactly how far I have to go, what my total time is, and what my total fuel is. And there is VFR flight planning in a nutshell. Now, the one thing you do also want to know about is, as we're doing our flight plan, is there any restricted airspace? Is there any other controlled airspace that we have to contend with? And the answer here is not really. The Cessna's not going to climb into Class B airspace. There's no way it's going to climb fast enough to get into Class B airspace. That's Tampa. If you're on course, you don't have to worry about Lakeland. Lakeland is Class D, as is Bartow. If you're on course, put the plotter down here. That's on course. So if you're in Lakeland's airspace, you're about 5 miles off of your course. You should be turning around and going back and checking your flight plan. And then as we come down further to the southeast, we do have the magenta hashed, but that is not restricted. That's just a MOA. You can fly in the MOA legally. Just keep your head on a swivel like you always should. Avon Park is not a controlled airspace. It's just a uncontrolled airport. So is Sebring. It's not controlled airspace. So you can land there just using Unicom. Last but not least, you do have the blue hashed over here. That is the restricted airspace at 2901, which we call Avon Park restricted airspace. And you do not want to go in there because there are some crazy stuff going on. A lot of military aircraft, a lot of P-51s up out of Orlando. And I've actually seen bombing missions going on out here. They will actually release live bombs. So you got to watch out. That's why you want to make sure you're on course and you're following your flight plan just like that. All right, that's our lesson for the day. If you guys have any questions, obviously ask. This is just a great way to get your flight planning started, and eventually you use your tools enough, right? Your plotter and your battery-free whiz wheel, and you'll be an expert at doing flight planning, VFR flight planning. Have a good day. Happy tailwind. See you in the air.